There is a quadratic expression given over here, 30x squared positive bx positive 33. A factor of the expression above is px positive q, where p and q are positive integers. What is the least possible value of b? Okay, now in the given quadratic expression, we have to find the least possible value of b, which is a coefficient of x. Okay, so to solve for the least possible value of b, what I'm going to do is I'm going to consider the given quadratic expression as quadratic equation by equating this expression to 0. Okay, let me write it. 30x squared positive bx positive 33 equals to 0. Okay, I've considered the given quadratic expression as quadratic equation. Okay, if I want to solve this quadratic equation by factoring, what I need to do is I have to multiply this constant term positive 33 by the coefficient of x squared, which is positive 30. When I multiply positive 33 by positive 30, I'm getting positive 990. Okay, now what I need to do is I have to get two factors over here for positive 990, so that the product of the two factors equals to 990 and the sum of the two factors equals to the coefficient of x, that is b. So now I have to get two factors for positive 990. So here, if I consider the two factors of positive 990, both the factors must be either positive or negative. So because the number 990 over here is positive, so if the first factor of 990 is positive, the second factor also must be positive, so that when I multiply positive and positive, it will be positive. Otherwise, if the first factor is negative, then the second factor also must be negative, so that when I multiply negative times negative, it will become positive. So it's not possible to have different factors for the two factors over here. That is, one is positive and other one is negative. So what if I have one is positive and other one is negative? When I multiply positive and negative, it will become negative, but the number we have at the top is positive. So both the factors must be positive or negative. So how do we have to decide that both the factors are positive or negative? So okay, for that we can consider a quick example to understand this problem. Let me consider a quadratic equation, that is x squared positive 5x positive 6 equals to 0. Okay, now let's solve this quadratic equation by factoring. For that, we have to multiply this constant of positive 6 by the coefficient of x squared, that is 1. So 1 times positive 6 is positive 6. Okay, now I have to get two factors for this positive 6, so that the product of the two factors equals to positive 6 and the sum of the two factors equals to the middle term, I mean the coefficient of x positive 5. So I think positive 2 and positive 3 will work. When I multiply positive 2 positive 3, I'm getting positive 6. When I add them, it is equal to the coefficient of x, that is positive 5. So then the two factors of this quadratic expression over here is x positive 2 times x positive 3 equals to 0. Okay, so here the product of the two quantities equals to 0. Either the first quantity, I mean x positive 2 equals to 0, or x positive 3 equals to 0. Okay, now let's solve for x in this equation. For that, I have to subtract 2 from both sides. When I do so, I'm getting x equals to negative 2. And if I solve this one for x, I'm getting x equals to negative 3. Okay, now I got two values for this quadratic equation. That is, one is negative 2 and other one is negative 3. Okay, when I solve this quadratic equation, so the one of the values of x over here is negative. And the factor corresponding to this negative value of x is positive over here. So when I solve a quadratic equation by factoring, if I get one of the values as negative and the number, I mean the factor corresponding to this negative value of x will always be positive. So let's apply the same logic in our problem. Okay, so let me go to the our problem. Just a moment. Okay, here we know that one of the factors of the given quadratic expression is px positive. It's a linear factor, and in this linear factor, both the constants p and q are positive integers. Okay, so one of the factors of this quadratic expression is px positive q. So whenever I factor a quadratic expression, I'll be getting two linear factors, and one of the linear factors is given. So the other linear factor is unknown. Okay, it's not known. Okay, we can keep this one empty because we do not know the other linear factor. Okay, anyways, the product of these two quantities equals to 0. I mean, the product of the two linear factors equals to 0. So either this one equals to 0 or this one equals to 0. So then if I equate px positive q is equal to 0, then I will be getting one of the values of x for this quadratic equation. So I don't equate this factor to 0 because it's not known. Okay, now let's solve for this. Let's solve for x in this equation. For that, I have to subtract q from both sides. When I do so, I'll be getting px equals to negative q. And when I divide both sides by p, I'm getting x equals to negative q over p. Okay, now I got the one of the values of x for this quadratic equation, that is negative q over p. Okay, so I got this value x equals to negative q over p using the linear factor px positive q. And also there is an information that p and q are positive integers. Okay, both p and q are positive integers, then the value of this fraction will be positive because q is a positive integer, p is a positive integer. When I divide two positive integers, it will be a positive value. Since we have negatives in front of a positive value, so this is completely negative. So that means the value we got for x over here is a negative value. And the factor corresponding to this negative value of x has to be positive over here. So now from this information, that is from the linear factor px positive q, and this information p and q are positive integers. So we got the one of the factors of this 990 is positive. Then what must be the sign of the other factor? The other factor also must have positive sign. So that when I multiply two positive factors, we'll be getting a positive number. Okay, anyways, so now I understand that both the factors of 990 are positive. So how do we have to get those two positive factors for 990? Okay, let me start by taking a positive 1 as a first factor for 990. Then the corresponding second factor will be positive 990. So that when I multiply these two values, I'm getting 990. So when I add them, so that's a coefficient of x in the quadratic equation, that's a value of b. So the addition of the two factors I'm writing over here is the value of b. So when I add them, I'm getting positive 991. That is when I add 1 and 990. So this is a value of b, which is a coefficient of x. Okay, now I got the value of b, that is positive 991. But the target of the question is to find the least possible value of b. That is, we have to find the smallest value of b. Okay, for that we can try other pairs of factors like what I've done over here. So here I started with positive 1. Now I start with positive 2 as the first factor. Then what must be the second factor over here? So to know the second factor, what we can do is we can divide this 990 by this number. When I divide 990 by 2, I am getting 495. That is positive 495 is the second factor. So that when I multiply this one and this one, I'm getting positive 990. So when I add them, I'm getting positive 497. So this is a value of b. But again, the same reason, we have to find the least possible value of b. So when I try the first pair of factors, positive 990, I'm getting the value of b as 991. So for the other pair of factors, the value of b is getting decreased from 991 to 497. Anyways, so we have to keep trying the possible pairs of factors until we get the least possible value of b. So now we can try positive 3. If I take positive 3 as one of the factors, other factor has to be positive 330. So I just divided this 990 by this 3 so that I get the second factor. Okay, when I multiply positive 3 and positive 330, I'm getting positive 990. So when I add positive 3 and positive 330, I'm getting 333 as the value of b. In this way, we can try the factors too. Positive 4 will not work because positive 4 will not evenly divide this 990. So we can try positive 5. When I take positive as the first factor, the second factor I'm getting positive 198. So then when I add 198 and 5, and I'm getting 2 or 3. Okay, now let me list out all the factors because the value of b, that is when I add the two factors, so the value which we are going to get over here, that is the addition of two factors. So that's the value of coefficient of x, that's the value of b. Okay, anyways, let me list out the other possible pairs of factors. Here I have listed out the other possible pairs of factors for 990. So when I do so, and when I'm taking a pair of factors positive 13, positive 33, I'm getting the sum of the factors equals to 63. So that's the value of b. So anyway, so when I try the different pairs of factors, so initially I got the sum of the two factors is 991. When I tried the other possible pairs of factors for 990, so the sum of the two factors, I mean the value of b is getting decreased. At one stage I reached the value of b is 63. Okay, now the other pair of factors will be, I think 31 will not work because 31 will not divide this 990 evenly. 32 also will not divide. So 33, and the other factor will be 30. So because when I divide this 990 by the first factor 33, I'm getting 30. So again, I'm getting the same value 63 over here when I add these two factors. Okay, so now when I try the pair of factors 30 and positive 30, positive 33, I'm getting the sum of the two factors 63. So in the next pair, again, I'm getting the same sum, and also these two factors are switched over here. So so once the factors are switched and we get the same value as the sum of the two factors, and if I try positive 34 or positive 35, positive 36, positive 37, whatever number I try after positive 33, the sum of the two factors will be greater than 63. So because we started with the 991, when I keep on increasing the first factor, the value of the sum of the two factors, the value of the sum of the two factors is getting decreased. At one stage, it reached 63, and after 63, the factors are switched. Again, I'm getting the same value as the sum of the two factors. So once we reach this position, and if I try any other number after positive 3, so then the value of the sum of the two factors will start increasing. So the least possible value for B, the given quadratic expression is 63.